Good morning, everyone. My name is Bala Murali, AP2 in EC Department of KPR Institute of Engineering Technology. By continuation of historical development of electrons or in the form of digital technologies, uh, so we are going to see about transistors. So today we are going to see about the transistors. So regarding the introduction, by definition, a transistor is a semiconductor device. So since they are made up of semiconductor materials, uh, it's a semiconductor device which is used to amplify or switch electronic signals as well as electronic powers. So amplification means the input will be getting magnified into multiple and available as output. So that is one form. Then switching means it's a wide application. It is widely used in digital devices. So here the zeros and ones and the binary things will be happening due to the transistor on and off, so that they create on zeros and ones. So it's a semiconductor device. It is not fully a conductor. It is not insulator. It is a semiconductor device. So whenever needed, they'll be doing the conduction. Then regarding the invention, so they are invented during 1947. So by mainly William Skotsky at Bell Laboratory. So before that, we have used vacuum tubes. It has its own application, but the only difficulty is because of its large size, we had all the machines made up of them with a very huge size. That is one of the disadvantage why we haven't used. Why we need another applications after the vacuum tube, another devices after the vacuum tubes. Then that kind of one is nothing but a transistor. So, see, as I told you, they are replaced bulky vacuum tubes and revolution in electronics. So, they are the starting point for the that is revolution of electronics era. So, they have fully replaced the vacuum tubes. So after that only the fully big kind of electronics equipments have been made into compact. Then regarding their basic construction, so they are made up of semiconductor materials. So mainly the silicon. And based on the applications, they are also being available with germanium as well as some composite materials like gallium arsenide. So, so these are the main materials used for the construction of transistors. Then the transistor is of two main types. So that is nothing but bipolar junction transistor and field effect transistors. So bipolar junction transistor means it forms a junction. So mainly they are voltage control device. So uh, that is the applied voltage will be so basically these by BJT and FIT are either voltage controlled or current control device. So in case of this field effect transistors, so the applied field controlling the current, so they are called as voltage control device. But bipolar junction transistor current control device. So the main current I will be controlling the devices. Then field effect transistor means the applied voltage will be creating some electric field, that electric field controlling the transistor operations. So that is why it is called as a field effect transistors. Then usually BJT and FET devices are made up of three kind of terminals. One is emitter, another one is a base, the third one is collector in terms of BJT, and in terms of FET, one is source, then one is gate, then the final one is drain. Uh, then regarding their working principles, so they'll be controlling the flow of current through semiconductor junctions. So mainly they'll be having some junctions, so like multiple PN junctions. Mm. The flow from one point to another point will be happening them. Within there, the applied current will be getting controlled for certain applications. Then a small input current BJT or the voltage at FIT controls a larger output current. So a small current will be getting applied to them, or small voltage will be getting applied to them. Then the output drain current will be available as a large value. So that is controlled by the small amount. That's why this is called as a amplifier. So that's the main application. So it works as amplifiers, switches, and signal modulators. As I told you, one form of signal can be converted into another form of signal, that is called as signal modulator, or an amount of signal can need to be carried from one point to another point. We can use this modulator. Then type of transistors, as I told you, it is bipolar junction transistor. So it is available in two types, one is NPN and PNP. So in case of NPN, so two junctions will be getting formed from N to P1 junction, P to N one another junction. In PNP, P to N one junction, N to P another junction. So likewise, multiple PN junctions will be happening in bipolar junction transistors. So two different poles will be getting combined to form a junction. Uh, to form a diode, then they have a junction between them. Then field effect transistors. So mainly they are JFET and MOSFET. They are available as metal oxide semiconductor field mm, effect transistors, the MOSFET. Then JFET junction field effect transistors. So these are the two different varieties. Then they are also available as a specialist tubes like IGBT, then photo transistors and power transistors. So based on their applications, their requirement, they are not in multiple ways. Then regarding the applications, so they are the main elements for integrated circuits. In all the ICs are made up of these transistors. Then all the microprocessor equipments having a transistor in their motherboard, so that multiple thousands and millions of transistors are working together for that application. And also they'll be used in memory devices to store zeros and ones. So based on their operations, either zero, either on and off, they'll be storing ones and zeros in memory devices. Then they also mainly used in signal amplifications like radio and audio systems. So mainly in audio systems, when a small amount of input is given, they will be getting magnified and available as a very large output. At the end, in radio use also a small amount of wave to be transmitted to larger distance in a larger volume. So that kind of amplification will be done by the transistors. Then they are mainly used in digital logic circuits like computers and smartphones. So in computers, all the internal motherboards are made up of some billions of transistors. So they'll be intending for their particular operation. And then they are also used as a power regulators. Then also they'll be used in the switching applications. So they'll be used in SMPS and motor controlling devices. Then regarding their advantages, they are very small in size when compared with vacuum tube. So vacuum tubes are bulkier in size, but the transistors are very smaller in size. Then they are very light when compared with vacuum tubes. So vacuum tubes, because of the cathode and anode electrodes, so they had very large weight, so that weight is controlled here, it is reduced here due to their configuration. Then when compared with the vacuum tubes, they are very low power consuming devices, then they'll be offering very high efficiency when compared with them. Then their lifespan is very long, then they are very highly reliable. So since there is no much amount of heating procedure here, so they have very long lifespan, and also their reliability is high due to this unwanted heating. Then they can be integrated into billions of transistors on a single chip. You're seeing one IC can be made up of billions of transistors. So by integrating them, we can do our make we are made up of made our applications. Then regarding the limitations, so they are very sensitive to electrostatic discharge, especially MOSFET kind of devices. They are very much sensitive. So the controlling of them is very important there. Then they have very limited power handling capability. So when compared with vacuum tubes, where they can able to produce and control very high amount of power, where they can able to handle very high amount of power. Even in terms of micro frequency ranges, they can able to work in industrial heating applications. They can able to work, but transistors are limited in such environments. Then regarding their impact over the technology, uh, because of their implementation, their invention, they have enabled the electronics into miniaturization. So most of the large electronic machines are become smaller now. As for example, the computer machines which were very high or very bulky in olden days now reduced to very smaller tablet, then laptop kind of devices. Even our mobile phones, which are bulkier in size, or TV, which is bulkier in size, have been reduced into small amount that is small cap area devices. So that is one impact. Then they put the foundation for modern computing and communication systems. So their development has is nothing but a seed for modern computing and communication systems. Then they are the key driver for digital revolution. So their invention is a key for all the digital revolution which we are doing now. So the obtained digital revolution mm, is happened only because of the invention of the transistor. So without transistor, we can imagine the digital world this much of that is with this much of advancement. So as per the Moore's law, we know that so once in 18 months, the transit number of transistors in a device will be getting doubled, then their cost will be getting halved. So that is a reason why this electronic industry has developed this much. Yeah. So these are a few points on why we need transistors. That is how they are developed, where they are applied, then why we need them, and then what we can do, then what are the limitations of them, then how they have impacted the technology. So thanks for watching.